Beneath the forest floor lies a hidden world, silent yet alive. Thin white threads stretch through soil and wood, weaving connections that we rarely notice. They are not roots, not plants, and not quite animals. They digest stone, recycle death, and nourish life. This secret network has been here for millions of years, shaping ecosystems quietly. And now, for the first time, we are learning to shape it in return. Imagine houses grown instead of built, clothes that sprout instead of being stitched, food that tastes like meat but comes from no animal at all. This is the power of mycelium. When most people think of mushrooms, they picture the caps that push through the soil or sprout from a fallen log. But those caps are only the surface. The real organism is hidden underneath. Mycelium is a living network of tiny threads that spread out like veins in the ground. Each thread, called a hypha, is hollow and flexible, able to stretch and divide endlessly. This web works like both roots and a stomach. It breaks down organic matter and absorbs the nutrients. Fallen leaves, bits of wood, and even waste from plants all become food. The mycelium binds loose material together, turning scattered fragments into one connected mass. Scientists have discovered that these underground webs are not only efficient recyclers, but also strong natural glues. This binding ability makes them perfect for creating new kinds of materials. Unlike plastic or concrete, mycelium does not need high heat or chemicals. It simply grows into whatever shape it is given. That is why companies and researchers see it as more than just a curiosity of the forest. Mycelium is a living toolkit. With the right conditions, it can transform waste into packaging, bricks, fabrics, and even foods that resemble meat. The first big step in using mycelium came from a simple idea. What if it could replace plastic packaging? Two young inventors tested this by mixing farm leftovers like corn stalks and hemp husks with mycelium. Instead of throwing this waste away, they placed it into molds and let the fungus grow. Within days, the threads spread through the mix, filling every gap and forming a solid, lightweight block. Once the growth was complete, the material was gently heated. This stopped it from spreading further and gave it a stable shape. What came out was something remarkable: packaging that could protect fragile products like electronics, yet return harmlessly to the soil when discarded. It worked like styrofoam, but left no pollution behind. This innovation attracted attention from major companies. Brands that wanted to cut down on plastic waste started to experiment with it. Because the process was fast and inexpensive, the idea spread quickly across different industries. The appeal was clear. Mycelium packaging turned agricultural trash into useful products, avoided landfills, and offered businesses a greener image. What began as a small experiment grew into a new industry, showing how fungi could take on one of the biggest problems of modern life. The success of packaging opened the door to something larger. Instead of working with small molds, researchers began to imagine entire facilities where mycelium could be grown like crops. But these crops did not need sunlight or fertilizer. They thrived in dark, cool rooms filled with sawdust, wood chips, and other plant waste. Inside these indoor farms, racks stretch from floor to ceiling. On them, mycelium spreads across trays in wide sheets, forming thick mats of pure fungal tissue. In less than 2 weeks, these mats will reach a size ready for harvest. Unlike traditional farming, there are no seasons, pests, or droughts to worry about. The process is predictable and steady all year long. Because the fungus recycles moisture from the material it consumes, it needs far less water than crops, such as cotton. It also avoids the heavy energy use of synthetic materials like plastic. What results is a quiet kind of agriculture. No tractors, no irrigation, just a cool room where life grows from waste. This shift turned mycelium from a novelty into an industrial material, ready to compete with the building blocks of modern manufacturing. As the sheets of mycelium rolled out of these farms, designers quickly saw their potential. By pressing and finishing the material, it could look and feel like leather. Soft, flexible, and durable, it carried the same appeal as animal hides, but without the environmental cost. Traditional leather requires livestock, large amounts of water, and chemical tanning that leaves behind toxic waste. Mycelium leather skips all of that. It grows in less than 2 weeks, uses only agricultural leftovers, and can break down naturally at the end of its life. Fashion brands began to take notice. Shoe companies tested it for uppers and linings. Luxury labels experimented with bags and jackets. Because the material can be grown in large sheets, it avoids the irregular shapes of animal hides, reducing waste. It also accepts dyes easily, giving designers freedom without relying on harsh processes. For the fashion world, it opened a path to style that was both sustainable and scalable. But mycelium was not limited to clothing. Food scientists also discovered how to shape it into something familiar: meat. By slicing thick layers of fungal tissue and curing them with smoke, salt, and natural flavors, they created strips that looked and cooked like bacon. In the pan, they sizzled and crisped, just like the real thing. The taste was close enough to fool many who tried it. The environmental difference was dramatic. Instead of raising pigs on land and feed, these fungal strips grew on waste material inside a warehouse. They required little energy, produced almost no greenhouse gases, and left behind compostable scraps. Soon, new versions followed: pulled pork, burger fillings, and other plant-based meats with a texture that felt closer to animal products than soy or pea protein. In fashion and in food, mycelium offered something rare: sustainability without compromise. Beyond packaging, fashion, and food, mycelium has begun to appear in places no one expected. Small startups have used their foamy texture to make earplugs that can be thrown away without guilt. Sports companies are testing surfboards with fungal cores instead of plastic. Even funeral services are exploring coffins grown from local mushrooms and plant fibers, offering burials that return every part of the body to the soil. Its ability to absorb sound has also inspired new uses. In Italy, companies press it into panels for walls and ceilings. These panels soften echoes in offices and studios while replacing synthetic foam that lingers in landfills. Designers in Northern Europe have built cabins where the walls are lined with mushroom sheets for insulation. Even the furniture inside, from stools to benches, was grown rather than manufactured. Builders in Africa have gone a step further by producing bricks from fungal fibers and invasive plants. When pressed and hardened, the bricks reach surprising levels of strength, sometimes even outperforming concrete in basic tests. They are light, resistant to fire, and can be made from local materials at very low cost. In California, an upcoming housing project plans to cover hundreds of apartments with large panels made from mycelium mixed with hemp. Once sealed in protective layers, the panels act as insulation, cutting energy bills while also locking away carbon. The project shows how this living material can be scaled up for real cities, not just experiments. From tiny earbuds to entire buildings, mycelium is finding a role. It is becoming a building block for everyday life, both ordinary and extraordinary. If mycelium can replace plastics and bricks here on Earth, what else could it do? Scientists are beginning to ask if it could even help us live beyond our planet. At NASA, researchers are testing the idea of sending dormant spores to the Moon or Mars. Instead of shipping heavy construction materials, astronauts could carry lightweight frames seeded with fungi. With the addition of water and plant waste, the mycelium would grow into walls and domes, forming protective shelters far from Earth. This idea is more than science fiction. Mycelium is naturally good at shielding against radiation and can pair with algae to produce oxygen and food. Together, they could create self-sustaining habitats in extreme environments. Early tests in orbit are exploring whether the fungi can grow in microgravity and still form strong structures. Here at home, researchers are experimenting with mycelium as living electronics. At Cornell University, engineers wrapped fungal threads around tiny sensors. When exposed to light or moisture, the mycelium produced signals that machines could read. Robots equipped with these biosensors reacted by moving or changing direction. Because the fungal network is so sensitive, it could one day act as a natural detector for soil health, pollution, or chemicals in the air. One of the most striking qualities of mycelium is not only its ability to become new materials, but the way it changes how we think about resources. Most of what we use today comes from mining, drilling, or complex factories. These processes consume vast amounts of energy, leave behind waste, and create products that linger for centuries after they are thrown away. Mycelium follows a different path. It grows in simple conditions, thrives on agricultural leftovers, and transforms itself into useful goods that eventually return to the soil. A block of packaging, a piece of leather-like fabric, or even a sturdy brick made from fungi never becomes permanent waste. When its job is finished, it breaks down into nutrients that feed new life. This cycle is the foundation of a circular economy, where products are designed to regenerate rather than pollute. Looking ahead, mycelium could become as familiar as wood or steel once were. It offers strength, adaptability, and sustainability together. It is not just a substitute, but a vision of balance, growth, use, and renewal working in harmony.